So when we are going to have more than 2 subscripts in an array, in order to access that element, then we are going to call that as multi-dimensional array. We are only focusing on the operations and behavior of an particular data type. Then we are going to call that as a abstract data type. Array size must be known when the array is created. That is why it is considered as what? Static or fixed size of an array. Hello everybody, a warm welcome to one and all. Welcome back to the last session of your chapter 2 of unit 1 of B.C.A's second semester subject called Data Structures Using C. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. As we all know that in the chapter 2 of this unit 1, we are learning about the concept of arrays, right? So in the previous session of this chapter, we had a discussion regarding the types of array. Amongst that we have one-dimensional array or one-dimensional array or 1D array. Next we have a two-dimensional array, and if it is crossing more than 2 dimensions, then we can say that as multi-dimensional array. So in the previous session of this unit or this chapter, we had a discussion regarding two-dimensional array. So what do you mean by two-dimensional array here? So if you are accessing the content of array, or if you are accessing any of the elements with the help of 2 subscript, then we are going to call that as a two-dimensional array. So one subscript specifies the row and another subscript specifies the column. So it will be in the formation of table because rows as well as column will be there. And also we have learned regarding multi-dimensional array. It's an array of array. So when we are going to have more than 2 subscript in an array, in order to access that element, then we are going to call that as multi-dimensional array, and it can be n dimension, which is greater than 2. And also I have discussed regarding the basic operations, whatever we can do on this array. So how to remember that? That is TID SMS, right? What are the operations we have? Traversing, insertion, deletion, searching, merging, and we have a sorting. So these are the different operations we can perform on this array. As the last concept of this arrays topic, we are going to learn about why array is considered as abstract data type. In short, it is ADT. So why it will be considered as abstract data type, that I will be discussing. Along with that, we'll see what are the advantages and disadvantages that we can have in this arrays. At last, we'll see how this linear array will going to be represented in the computer's memory. This is what we will be discussing in our today's session. Let me get into the session that is with respect to arrays as abstract data type. Already we know, right? What do you mean by data type initially? So when we are specifying a type of data, let me take one example here. If I am considering int a, what it means? So here I am declaring a variable called a, which is of a data type integer, right? No? And the same way I am going to take char b. So here b is the variable name, and that belongs to the data type called character. That means it has the ability to hold only character type of data. So in this abstract data type, we are only focusing on the operations and behavior of an particular data type. Then we are going to call that as a abstract data type. So it will going to focuses on the operation as well as the behavior. But here, how it will going to perform the operation? It will showcase whatever the operations and behavior it will going to perform, but how it is performing, that internal working will not going to be shown to the user. That hidden operation, that operation will going to be hid by the user. That is what arrays as abstract data type. So we are going to call an array as an abstract data type because they are capable of holding contiguous element in the same order. As we all know that when we calling that as an array, then it will be a collection of homogeneous element, and that collection of elements will going to be stored in a contiguous memory. That means one element will going to be stored after another element. That is what contiguous or continuous elements will going to be stored in same order. And if we get to know the first address of an element, for example, consider I have 5000 elements in my array. So if I got to know the address of first element of an array, then it will be easy to find out another 4999 element. So why? Because this will be contiguous in nature. One element will going to be settled after another element. And also how we are going to access that element, that for the specific element can be accessed with the help of index or position. For that index or position, we are going to call that as a subscript, right? With the help of this subscript, we can find the position of an element in the set of elements of an array. So they are abstract because they can be string, integer, or even a person. So here we can take any kind of data type for the array. So it is not only restricted to have only integer value or a floating point values or a character value or a string value. It can be any kind of data type. But whatever operation that it is doing internally, that will not going to be showcased, that is going to be hidden from the user. That's what it is considered as what? Abstract data type. So here you can see the example. We are declaring an array that is int is a data type here, and without that size we are explicitly taking, and name of an array is ARR. So with the help of this new keyword, we are initializing that. And also we have one more declaration of an array with a data type called string. In the same way, we are taking one more array with a data type called person. So here this person is treated as defined class. And also here we are specifying its size. That means it is not only restricted to have only integer or a string or any of character or float. That is not the thing in the arrays concept. It can be any kind of data type, but the elements will going to be stored one after another. To access that element, we have to use this index or subscript, or that specifies the position. This is considered as what? Arrays as abstract data type. So next, here we'll see what are the advantages we can expect when we have this array, or why we have to use this array. Why? Because it's so fast in nature. Whatever the accessing we are doing, inserting, deleting, and whatever the operation it is possible on the arrays will going to be fast in nature. And random access of items or elements. So we can pick it up the elements, or we can access that items or elements in a random manner. And also very memory efficient. How many number of elements that I wanted to take, only that much of memory will going to be allocated. That is why it is efficient in terms of memory, and very little memory is needed to store the contents. So it is not taking much memory space in order to store the data. And arrays to multiples data of similar types. So of a same type, it is capable of holding multiple number of elements. That is also one of the advantage with a same name. If I call vegetables, then that number of vegetables comes under that category. If I say bicycle, number of bicycles will come under same category. That means we can have n number of elements which comes under the same category with the same name. So that kind of elements can be stored in the arrays concept, and it is helpful to store any type of data with a fixed size. And also we can restrict the size. For example, if I am taking 5 kg bag, then it is restricted to hold only 5 kg. And in the same way, if I specifying the number of seats as 100, then only up to 100 seats only we can entertain. So this is what we can do in the arrays concept also. Then what are the disadvantages we can expect? That is slow insertion and deletion of elements. For example, I have 500 elements. I wanted to store the elements, or I wanted to insert an element in the position of 501. Then it needs to follow every step. That means it has to visit every element. Then it needs to find the element where we wanted to insert, whether we wanted to insert an element at the last, at the beginning, or middle, anywhere in the set of elements. Everything needs to be analyzed. Then only, that's the reason this is considering as what? Slow in terms of inserting and deleting of an element. And array size must be known when the array is created. That is why it is considered as what? Static or fixed size of an array. So instead of giving random numbers to the size, we have to specify the exact number of size. For example, if you are booking for a show, then I have to specify only 5 people. If it is 5 people, all the 5 should be present there. So there can be less number, but it can't exceed the range. That is what? Static in nature. These are the advantage as well as disadvantage that we can face when it comes to the arrays. So next, last concept of this chapter, we'll see how we are going to represent the linear array. That is, usually if it is linear, 1 by 1. If it is 1 by 1, obviously it is of one-dimensional array. So how we are going to represent this linear arrays in the computer's memory? That is what we'll see. The elements of one-dimensional arrays are stored in contiguous memory location. How the memory location will be in the representation of elements in an array? That will be in the terms of contiguous memory allocation. One element will going to be stored after another element's memory location. And also, you just take the example of char A of 5. What it means usually, if I am declaring an array data type, then I need to specify the name of an array. Within the square bracket, we have to take a size, right? So what it means here, I am declaring or I am taking an array called A and it is of the data type character. This A array is able to hold or to have a collection of only character and up to 5 character it will going to hold. Then how it will going to be represented? Consider A, B, C, D, E, right? Why? Because this is character in data type. That is what. And also, how can I represent that? A of 0. Always array's index starts with 0th position. A of 0 and it will be A of 1. It is A of 2 and this is A of 3 and this is A of 4. So, how we are going to find the last index? That is always n minus 1. N is 5 here, minus 1 will be 4. So, the 4 will be the last position or index of this array. Then, what is the memory location? If I get to know the memory location of a first element, for example, consider this is 5000. Right? It is in the memory 5000. This is random number compiler generated memory address. Right? So, if it is character data type, this is of 1 byte. Then, what is the contiguous memory location specifies? So, if it is 5000 location or memory address, the immediate next value must be 5001 only. Right? Why? Because this is of character data type and next will be 5002. 5003, 5004. This is how the memory location will be considered as what? Contiguous memory location. So here, A of 0 is allocated at a particular memory location. So that can be anything. I am taking just 5000 as an example here. And A of 1 is allocated at the next memory location and we are going to continue up to the size of an array. So that array is one of the type char. Each element requires 1 byte. So based on the data type, it will going to allocate the memory space for the further elements. So here, let me consider M, N, O, P, Q. So these are the elements. These are the location or index or subscript and this specifies the memory space or memory location. Right? So this is going to be generated by the compiler. This is how we are going to represent a linear array in computer memory. We'll see the same thing with respect to integer number. So here you consider int A of 3. So what it represents? Already we know that for the integer, it will be of 2 byte or 4 byte. It will be based on the type of processor that we are using, right? Usually it will be of 2 bytes. At that time, if the first element is in the 500 or 5000 memory location, then the next element should be in 5002. Why? Because 2 bytes of memory is required for a single values or for the single element. So here you can see that representation. 5000 and 5001 will be considered as what? A of 0, that is, it's in the first position. Next for the A of 1, it will be 5002 and 3. Next location 5004 and 5. So here we are going to store the element. It will be, if it is integer, then it will going to be 2, 4 and 6. It will be within that range. So 2 bytes will be for first element, another 2 bytes will be for another element, the last 2 bytes for the last element of this array. Here also same thing. A of 0 is allocated at a particular memory location and the further allocation will going to be taken place. What if the array is declaring in the terms of float data type? At the time, instead of 2 bytes, it will going to take 4 bytes. For example, float, consider B, and let me take the size as 2 itself. So here, this will be of 2 values and the name of an array will be B. This will be B of 0, that is first location, next B of 1. So here it will be of 4 bytes. Fine. Next 1, 2, 3, 4. This will be of another 4 bytes. So here the element will going to be stored here and another element will going to be stored here. So if it is 5000, then it will be 5001, 5002 and 5003. So this will be 5004, 5005 and 5006 and 5007 at last. So this 4 bytes of memory will be given for the first element, another 4 bytes of memory will be given for next element. So this is purely based on the type of data that we are taking, that specifies the data type, and based on the size, that much of memory will going to be allocated for a collection of array elements. So that is why we are going to represent the array in the terms of contiguous memory location. So here you can see that the amount of storage space required to hold an array is directly related to its type and the size of the array. How we are going to able to understand the storage space which is required to store that element, that is directly proportional to the data type, which kind of data type we are taking and what is the size. So if I am taking 2 values, that means consider I am taking 2 size of elements in an array and the data type is char. So at that time, what it will be, what is the data type size of a character? It will be of 1 byte, right? And number of elements will be 2. So if 1 byte multiplied with number 2, at the time it require only 2 bytes of memory location. How we are going to find the total size then? Total size is equal to size of type. I need to specify which is the data type. What is its size? Will be multiplied by the size of an array. Then we can get the total size which is required to store that element. So that the total size of char array required is 1 byte and I have 5 elements in that. So 1 into 5 will be 5 bytes. In the same way, for the integer, consider as of now it is of 2 bytes and I have 3 elements. Then 2 into 3 will be 6 bytes. This is how we are going to represent a linear arrays in computer memory. I hope you all understood my today's session. It's all about our unit 1. Let me meet you in the next session with the starting of this unit 2. Until that, keep learning, keep on growing. Thank you.